Let's take a look at the Unit 2 review. So for letter A, it says identify the types of bonds below. So we've got 4 types of bonds: molecular covalent, network covalent, ionic, and metallic. And I really think it helps to think of an example of each so that you can kind of picture that substance in your mind when you're thinking about the properties. So some things with molecular covalent bonding that we've worked with are sugar, nitrogen gas, water. Things that are with network covalent bonds: diamond, sand, graphite, like your pencil lead. Things with ionic bonding, the one you're most familiar with is sodium chloride, just the salts that you put on your food. You can probably think of lots of different metals, but something that a lot of people think of would be like nickel or copper, since those metals make up our coins. So what kind of bonding would have a soft solid that has a low melting point and a distinct smell? Well, the only thing that we tested in the lab that really had a low melting point was sugar, and it definitely had a smell after it melted. So the type of bonding that fits best with these properties would be molecular covalent. A solid that dissolves easily in water and has a high melting point, that would have to be ionic. Salt dissolves in water and it's really hard to melt. It takes a high melting point in order to turn it into a liquid. Number 3, carbon and oxygen are both nonmetals, and so because of that, this would have molecular covalent bonding. You might ask, why wouldn't it have network covalent bonding? But since it's a gas, that more matches the properties of molecular covalent. Something like number 4, though, that's cobalt. That's a hard solid, and that is definitely a metal. It's to the left of the zigzag. So that would have metallic bonding. Silicon, that's one that's right on the edge of the metals and the nonmetals. It's in sand, and so they will classify this one as having network covalent bonding. That's a tricky one, though. Let's take a look at what it wants you to do in part B here. It says draw a picture of the electron configuration. Since oxygen is number 8 and it's in group 6A, that means it has 6 valence electrons, 8 total electrons, and it's in period 2, so it has 2 rings. So the first ring has 2 electrons and the second ring has 6 electrons. That's what makes the total of 8. This part was done for us. It's to the right of the zigzag, so it's a nonmetal with 6 valence electrons. It wants to gain 2 to be like neon. Neon is in group 8A. That's the noble gases, and so it wants to be like number 10, neon. And when I say it wants to be it really just wants to have the same outer shell of electrons as neon. So it wants to have 8 electrons in its outer shell. So it will have to gain 2, and when it does, it will have a -2 charge. That's because oxygen has 8 protons, which are positive, and it normally has 8 electrons, which makes it neutral. But if it gains an extra 2 electrons, now the electrons are winning by 2. So that means it has a -2 charge overall. Lithium is number 3. It's in group 1A, so that means it has 1 valence electron, and it's got 3 total electrons. It's to the left of the zigzag, making it a metal, and it would like to lose 1 electron, because when it does, it will have the same electron configuration as helium. So when it loses 1 electron, it will have a +1 charge, because normally it has 3 protons and 3 electrons, but if it loses 1 electron, now the protons are winning by 1. Chlorine's number 17 in the third period, so it's got 3 rings. It's in group 7A. That means it has 7 valence electrons. It's to the right of the zigzag, making it a non-metal. It would like to gain 1 to be like argon. That's 1 to the right of chlorine, because then it will have the great 8 in its outermost shell. And we just talked about if you have more electrons than you do protons, that means you have a negative charge. For letter C, it wants us to combine some of these cations and anions, the positives and negatives, and to do that we want to crisscross if necessary. So sodium has a positive 1 charge, so when it combines with fluorine, the charges just cancel out. So you just get to slap the 2 atoms together and you're done. But when sodium and oxygen combine, that 2 crosses over here. You need 2 sodiums to satisfy that oxygen. That's because sodium has 1 valence electron. Oxygen has 6 valence electrons, and it really wants to gain 2 more. So 1 sodium isn't enough to make it happy. You need 2 sodiums to make that have a neutral charge overall. In a similar fashion, phosphorus would like to gain 3. So you need 3 sodiums to make an ionic compound with phosphorus. Sulfur has a negative 2 charge, and this one's interesting because lead has a +4 and sulfur has a -2, and so when you crisscross you get Pb2S4. And we learned that there are formula units, so you can simplify this as a 1:2 ratio, and you can just write Pbs2. How about lead fluoride? If you crisscross the charges here, you'll see that you need 4 fluorines to satisfy that lead, so it'll be Pbf4. This one is similar to the lead and sulfur. So when we combine the 2, we get Pb2O4, but we can simplify that to PbO2. And last but not least, when we combine lead and phosphorus, we get Pb3P4 for our compound. And that one's kind of a fun one to draw out because each lead wants to give up 4 electrons. So I want to give you a visual of how this all works out. Each phosphorus can only accept 3 electrons. So if you tried to start by saying, okay, how about a 1:1 ratio, you would see pretty quickly that that's not going to work out because there are still 3 more electrons that need a home. So we need that 4th phosphorus, and now everybody's happy. That's why it's Pb3P4. And since each Pb has a +4 charge and there's 3 of them, that's a +12 charge. And since each phosphorus has a -3 charge and there's 4 of them, that makes a -12. And a +12 and a -12 makes a 0 overall charge. For letter D, it's talking about forming a crystal lattice structure, or is it forming a molecule? And we learned that things with ionic bonding form a crystalline lattice structure. Things with covalent bonding form a molecule. So for calcium sulfate, that's a metal and nonmetals. That means it has ionic bonding and would form a lattice structure. But HCl is all nonmetals, so that would form a molecular structure. And the last one here is a metal and some nonmetals, so that would be another lattice. Alright, let's talk about naming. When you're naming something like LiCl, you just change the ending to "ide." So number 2 would be aluminum chloride. Number 3 would be sodium bromide. And this one's a challenge because it has a transition metal. So it wants you to figure out what must the charge of this nickel be if it's combined with one phosphorus. Well, phosphorus wants to gain 3 electrons. So if nickel is making it happy, that must mean that nickel wants to lose 3 electrons, making it have a positive 3 charge. So this would be nickel, Roman numeral 3, phosphide. We're crisscrossing here, and there's something new. Anytime you see a Roman numeral, it just means the positive version of that number. So Roman numeral 2 means +2. So for iron 2 bromide, if we're going to crisscross the charges, it would be FeBr2. Potassium has a +1, iodine a -1, so this one is just Ki. Calcium's got a +2, fluorine is a -1, so this would be CaF2. Titanium has a +4, that's what that Roman numeral is. Oxygen is a -2, so this would be Ti2O4, and we can simplify that to TiO2. Now we're naming some polyatomic ions, so these are the 6 that you needed to memorize. I made you memorize them a little bit early, so then you'd be definitely ready for this quiz. We've got calcium carbonate, aluminum nitrate, nitrate. We've got nickel. Since this is a transition metal, we need a Roman numeral, nickel 2 hydroxide. How did I know it was a 2? Well, OH always has a minus charge. And if there's 2 of them that are satisfying this nickel, that must mean the nickel has a +2 charge to cancel that out. And number 5 here, I just saw the numbering is a little bit off, would be ammonium nitride. Writing the compounds. Ammonium is NH4 with a +1. Chlorine is a -1, so those cancel out. Number 2, strontium has a +2. Hydroxide is a -1, so this would be SrOH2, crisscrossing that 2 over. Copper here, since it has a Roman numeral 1, that means it has a +1 charge. Sulfate has a -2, so this would be Cu2SO4. Cobalt here has a +2 charge. Nitrate has a -1, so this would be CONO32. These are just the polyatomic ions, again, that you needed to memorize. You can find these lists in many places in your notes, but here they are again for you. Get pretty good at writing them out once you've done it a few times. Jay says, pick 2 of the bond types and explain what's going on with the electrons. What are they doing? So in an ionic bond, a metal gives an electron to a non-metal atom. That is an ionic bond. Then the positive cation and the negative anion are attracted, and that's what holds the bond together. That's different from a covalent bond, where 2 or more nonmetals share electrons. So 2 atoms will share their electrons. And in a metallic bond, there's just a sea of electrons. I compared that one to going to a potluck, where everybody brings their electrons and they're shared and free-flowing everywhere. Letter K, what kind of elements would form a 1-to-1 ratio with nitrogen? Well, nitrogen would like to gain 3 electrons, so anything that would like to give 3 electrons would be a perfect match. So anything in group 3A, for example, aluminum. Letter L, draw a board diagram of magnesium and chloride. Show where and how many electrons are gained or lost by each. Since magnesium is number 12 and it's in group 2A, you know it has 2 electrons in its outermost shell. And I'm just going to redraw those as separate electrons here. 1, 2. Chlorine is in group 7A. It has 17 electrons. And I'm going to draw those electrons out, the 7 in its outer shell. It really wants to gain 1 more electron to be like argon. So magnesium will give 1 of its electrons to 1 chlorine atom, and it will give its other valence electron to a second chlorine atom. You need 2 because each can only accept 1 electron. Then magnesium, since it will have 12 protons still, but now only 10 electrons, it will have a positive 2 charge. And each chlorine will have a negative 1 charge because they have 17 protons and now they have 18 electrons. So the electrons are winning by 1. So now the compound that forms is MgCl2, and they all are attracted and hang out together. Good luck studying.